This is RD Sharma solution, class 12th. Chapter is 19. We are taking multiple choice question of indefinite integrals. In this question, we have cos 2x minus 1 divided by cos 2x plus 1. So we need to make it somewhat in a way that we get some tan or cot. We know the formula of cos 2x. In terms of sine also we can write, in terms of cos also we can write with half of that angle. So cos 2x we are going to write like this: 1 minus 2 sine square x. There is one more way in which cos 2x can be written. You might be remembering and recalling all these things. It can be 2 cos square x minus 1. Let's put it here. In place of cos 2x, I am writing 1 minus 2 sine square x. So minus 1 is there. In this cos 2x, we can write 2 cos square x minus 1. So 2 cos square x minus 1, and then we have a plus 1 also. What do you get? 1 and 1 gets cancelled in numerator as well as the denominator. 2 also gets cancelled. Only negative sine square x by cos square x will remain. So I am taking this negative outside the integral. Sine square x by cos square x can be written as sin x by cos x whole square. Sin x by cos x is tan x. So we can write it as tan square x. And sec square theta is 1 plus tan square theta. In place of tan square theta, you can write it as sec square theta minus 1 or sec square x minus 1. That's what we are going to write here. And negative is here, so you can just multiply this negative with sec square minus 1, and you can swap the places of 1 and sec square. Now we can write 1 minus sec square x finally. Let's separate them out and integrate. Integration of dx and integration of sec square x dx. What is integration of dx? It's x. What is integration of sec square x? It's directly tan x. So plus a constant of integration. So x minus tan x plus c is your correct answer. You can match it. Now this is how it needs to be done, and I hope that you will be writing down those formulas or identities which I just wrote in front of this question. Cos 2x minus cos 2 theta divided by cos x minus cos theta. So we have just completed a question, and in that question we have used certain formula or results. So 2 cos square x minus 1, in place of cos 2x you can write minus cos 2 theta. For cos 2 theta you can write 2 cos square theta minus 1. Please remember, cos x is cos x, but cos theta is a constant value. So I'm just doing the numerator right now. I'm opening it. 2 cos square x minus 1 minus 2 cos square theta plus 1. 1 you can wipe out. 2 you can cancel. 2 you can take outside because 1 got cancelled. Cos square theta minus cos square x remains. Cos square x minus cos square theta to be precise. A squared minus b square is a minus b into a plus b. Now I am coming to the integration. We have just resolved our numerator. So what we got out of numerator is 2 cos square x minus cos square theta. 2 I am taking outside. So we have cos square a square minus b square. Cos square x minus cos square theta is a minus b plus b. Cos x minus cos theta and cos x plus cos theta. Denominator is cos x minus cos theta. You can write it here. What is the benefit? You can cancel this cos x minus cos theta, numerator, denominator. Only twice of cos x plus cos theta will remain. So let's deal with this 2 later, and we have to integrate cos x and cos theta separately. I mentioned you cos x is cos x, but cos theta is just any other constant. So let me write it again. I equals to twice of integration of cos x plus cos theta. We will separate them out and integrate separately. Integration of cos x and integration of cos theta. Cos x integration is sin x and cos theta is sin theta. Okay. Now this is a problem which most of the people will do. But the problem here is, can you identify the problem what I did just wrong? I was telling you from the beginning that cos theta is just a constant. Cos x is cos x with respect to dx. But the problem here is, or the mistake I deliberately committed is, cos theta you can take outside, integration of just dx will happen. So this sin x will remain like that because integration of cos x is sin x, but integration of cos theta, we are integrating with respect to dx. So when you are integrating with respect to dx, cos theta just simply acts as a constant. You can just take it out. Integration of dx will be x only. So you are going to eventually get x cos theta. What do you get? X cos theta. Now you can match it with the 4 results of 4 answers. And which one of this is matching? Just see. 2 sin x plus x cos theta, which is the first one, I guess. This one. The first one is your correct answer. So this is how you're going to perform this. These for formula putting is equal for both of them. I'm not denying that. But the problem which will come to you is integration of cos theta. Sometimes people might just write it as cos theta. That's a problem. Now in this question, I have nowhere to start. Frankly speaking, I don't know how to start. But one thing caught my eye, and which is these 4 options. In these 4 options, 4 plus 1 by x square is common. So we have to do something so that we get 4 plus 1 by x square. So x raised 9 is the numerator. I am writing 4 plus 1 by x square, and we can get this after taking x to the power 12 as outside. Because if you see that it is 4 plus 1 by x square to the power 6, the denominator is something raised to the 6th power. So x raised 12 if you even multiply this inside, you will see that it will be, when it comes inside, it will be x square, because it is x square to the power 6. So x square will come inside. When you multiply x square inside, it will be 4x square plus 1. That is the whole idea. So when we take x square outside, it will be 4 plus 1 by x square, but x square cannot be taken outside because the power is 6. So x12 has to be taken out. So x raised 9 by x raised 12 will give you 1 by x cube. This 1 by x cube will go up. It will be x raised minus 3. So 1 by x cube, this is dx. 1 by x cube dx is the numerator. 4 plus 1 by x square is the denominator. And it is raised to the power of 6. Now just take t as 4 plus 1 by x square. When you take this dt by dx will be negative 1 by x cube. You know already 1 by x square how to differentiate it. But we have 1 by x cube dx in the numerator. Actually, it's not 1 by x square. I just mistook. X raised minus 2. So minus 2 divided by x cube. So there is a minus 2 which I missed. I'm so sorry for that. So, but we need 1 by x cube dx. For that, we want this negative 2 to be a goner, and that can be brought on the left. So negative dt by 2 is equal to dx by x cube. So negative 1 by x cube dx, now I'm writing or replacing it by negative dt by 2. So half negative dt by 2, I'm writing half outside. 4 plus x square was taken as t, so t raised 6. So you just have to integrate t raised 6 in the denominator. Take it upstairs, t raised minus 6. T raised minus 6 can be written as t raised minus 6 plus 1 divided by negative 6 plus 1. It will be t raised minus 5 by minus 5. This will be half minus 1 by 5 and denominator t raised 5. You have to bring it upstairs because the answer is like that. So what do you get? Negative 1 by 10, and this t raised minus 5, t was simply 4 plus 1 by x square. So we got the answer. I'm just writing it. Negative 1 by 10, t is 4 plus 1 by x square. I'm writing it in the denominator just now. And you have to bring it upstairs because the answer, 4 answers are matching like that. So 1 by 10, this goes up. 4 plus 1 by x square raised to the power negative 5 plus a constant of integration. Now match it. This is your correct result. So it was a good question. Alright, it wanted some effort. Now we have x cube divided by under root 1 plus x square. And this has to be equated to a into 1 plus x square raised 3 by 2 plus b under root 1 plus x square. A and b has to be computed. What is a and b? What is a and b? Once you integrate left, then anything which is coming on the right, we can equate it with a and b. So this x cube can be written as x square into x. Integration is already there. Denominator we have under root 1 plus x square dx. 1 plus x square can be taken as t. When we take t equals to 1 plus x square, dt by dx will give you twice of x. That means dt by 2 has become x dx. Now x dx, we will just replace it by dt by 2. So this integration will be dt by 2 dt. Here we have 1 by 2. X square, because still there, we can change this t equals to 1 plus x square in terms of x square. It will be t minus 1. So we can write t minus 1 in place of x square. So t minus 1 dt. Under root 1 plus x square is under root t. Now we can integrate it directly. We need to separate them out. So I am writing it again. Integration will be half, and first one will be t by under root t minus 1 by root t. So we'll separately integrate them. You know already we have done so many questions like this, but for the sake of completion we are going to do it just now. T by under root t, t raised 1 divided by t raised half, t raised 1, t raised negative half, power gets added, it will be t raised half. So half, t raised half you have to integrate for the first term. Second term is 1 by root t. It goes up, it will be t raised minus half. Half I am going to deal later. So it's simply 1 by t raised half, it goes up, t raised minus half has to be integrated. So t raised minus half will be, I'm just integrating these two with the power of x raised n, which is x raised n plus 1 divided by n plus 1. That is what we have to do. So t raised half plus 1 by half plus 1 first one, and t raised negative half plus 1 by negative half plus 1 second one. T raised 3 by 2 will come 3 by 2 in the denominator. T raised half will come 1 minus half is half only. 1 minus half is again half in the denominator. Now we have a 2 here. So it will get cancelled with the 2 in the denominator, because denominator of the denominator is numerator only. So actually it's 2 by 3. I'm just changing t by this 1 plus x square now, because t was taken as 1 plus x square, if you remember. So 1 plus x square raised 3 by 2 will come, which is actually now making sense on the right of the result which is given in the question. Under root 1 plus x square again here, under root half power is simply under root only. This half 2 goes up. Still I didn't tell you to multiply it by half. Actually I'm doing it right now. So 2 gets cancelled, 1 by 3 will remain. In the second term 2 gets cancelled, only 1 will remain. So I'm writing the final result because I have to match it with the right part of the question being given. So 1 by 3 1 plus x square raised 3 by 2 minus the root 1 plus x square. Now let's match it with this. A here 1 plus x square 3 by 2. I'm just simply writing the right part of the question, and you will see what is matching. Plus b under root 1 plus x square. So 1 by 3 is simply a is 1 by 3, and b is simply negative 1. So b is negative 1, and just match it. You are getting a proper answer here. A is 1 by 3, b is negative 1. And if you want to do it, it was a good question, and this is how it will be perform. Next one is x cube by x plus 1. Now just see the answer. There are 1, 2, 3, 4 terms. For that we need to go in for a different approach. What will be that different approach? X cube, I am adding 1 and subtracting 1. So I am adding 1 and subtracting 1. X plus 1 will remain in the denominator, but we are going to separate them out. How do we do that? X cube plus 1 divided by x plus 1. And just assume that it is 1 cube only. 1 by x plus 1. Now a cube plus b cube, you already know the formula. Alright, I'm just writing the formula directly because you are quite aware. I'm just changing this a cube plus x cube, or x cube plus a cube. X will take it as x, a will take it as 1. It will be x plus 1, x square minus x plus 1. Denominator you have x plus 1, minus 1 by x plus 1. So just cancel these two. X plus 1 gets cancelled. Minus 1 by x plus 1 is here. So we have x cube. Let me separate them out and then we'll integrate. X square minus x plus 1 remains like that. This is with dx. So we are integrating x square first, then we are integrating negative x, then we are integrating simply 1, which is dx only. All dx are there, okay? I don't write dx. You already know that dx will remain 1 by x plus 1. Then x square will become what? X cube by 3. So we are now approaching the answer. X is x square by 2. Integration of dx will x only. And this will be 1 by x plus 1 log modulus of 1 plus x plus 1 plus a constant of integration. How easy it is now. So let's match it. The answer which we got and the question, it starts with an x. So this is how we match. All of them are matched, and that's your actual result. So this is how this has to be done. It seems to be a difficult question, but when you just add a 1 and subtract 1, it will be like cheese. 1 by x plus 2 and x square plus 1. So now this is very highly unlikely in my opinion that this is going to come. But still, since this question needs, we apply the partial fraction or partial fraction content. So we have 1 by x plus 2. Denominator is x square plus 1. So this will be a divided by x plus 2. X square plus 1 is also there. So bx plus c divided by x square plus 1. Now if you know how to do this, just skip this part, which I am just going to tell. A multiplied by x square plus 1 will be done first. Then bx plus c will be multiplied by x plus 2. This is your second one. X plus c, x plus 2. Denominator will come as x plus 2 into x square plus 1. And left you have 1 by x plus 2 and x square plus 1. Now you can just cancel these denominator because we don't need it anymore. It gets cancelled out. 1 will be equal to, 1 equates to a, I'm multiplying now, ax square plus a plus b into x bx square, then twice of capital BX, then CX, then twice of C. Now let's match it. AX square plus BX square, you can take x square common. A plus B will come. Then we'll take the x term. 2BX plus CX. So 2B plus C, x will come. Then we have A plus 2C. 2c plus a. So 1 will be on the left. So a plus b, because there is no x square counterpart, a plus b will be 0. 2b plus c, there is no x counterpart, so it will be 0 again. 2c plus a has a constant on the left, which is 1. So a plus 2c is 1. Now when you solve it, I hope that you'll be able to do it. A will come as 1 by 5, B will come as negative 1 by 5, C has come as 2 by 5. We have done a 70 question exercise on that, so I hope you'll be able to do it. Now I am putting these values and then we'll integrate. A, B, C already found out. A was 1 by 5 divided by x plus 2. This second term, which is bx plus c, has come like this. Negative 1 by 5 x plus 2 by 5 divided by x square plus 1. So we are integrating it now with respect to dx. So I'll separate these into 3 different integration. 1 by 5 multiplied by integration of 1 by x plus 2 dx. These two means negative 1 by 5 x and x by x square plus 1. This is the second integration. Third one is twice of divided by 5 and integration of 1 by x square plus 1. So 1 by 5, 1 by x plus 1 will be simply log x plus 2, which now is approaching the right part of the question. Negative 1 by 5 x by x square plus 1, x square plus 1 you can just take it as t, you'll get a dt in the numerator. So that's it, that is how you can do. So it will be log only, minus 1 by 10 log of modulus of x square plus 1. Last one is 2 by 5. Again, it will be 1 by 10 inverse x by a formula will use x as x and a as 1. So 2 by 5, 10 inverse x plus c. Now let's match it. Log x plus 2 here. Yes. 1 by 5 is there. So 1 by 5 is already there. We don't have to do anything. We have to find out a and b. Remember. Now we have negative 1 by 10 log x square plus 1. So log x square plus 1. This one. A is matching negative 1 by 10. So a is negative 1 by 10. Now 10 inverse has 2 by 5 in front of it, so b 10 inverse x. B is 2 by 5. B becomes 2 by 5. A and B we got. This is what you can match, and this is how, if you really want to do it by yourself, this is how you can approach this question and solve it. So this is all about this exercise. Thank you so much. Have a good one.